Let us next look at the topic of buoyancy and buoyant force. So what is buoyancy? Suppose we immerse a body in a fluid, partially or fully, anyways, there is a upward force due to this fluid on the body. Okay, and this is called phenomena is called buoyancy, and the force, that upward force, is called as buoyant force. That's it. Next, is it some magic force that comes, or there is a reason why this force acts? Okay, so let us see why buoyancy force acts. Okay, we had discussed already that a fluid, suppose this is a area here, a fluid pushes this area perpendicularly, so there is a force perpendicular to this area. So suppose I take a perpendicular area here, fluid is pushing it, so I've drawn a small force here. As the depth increases, the pressure increases. So as pressure increases, the force also on a unit area will increase. So the force has increased here and here. Little more deep. Here area is like this, pressure is more, the force is also more. More deep, the force is even higher. So what we can see is that there is a uneven distribution of force here. Okay, and due to this uneven distribution of force, there is a net force, and this net force that acts due to the liquid on this body is called as buoyant force. Okay, we know why is it acting, but why does it act upwards? Let us see further. Okay, how do we know that the resultant of all these forces is one in the upward direction? Okay, so that we will see in the next part. So before moving on, let us see what is Archimedes' principle. Archimedes said that when a body is put in a fluid, it experiences an upward force equal to the weight of the displaced fluid. What does this mean? Suppose you put a body here. Okay. Initially there was no body. In this space, whatever fluid was there, that fluid has some weight. Okay, and this body is displacing that much fluid. That means removing it from its place. The buoyant force on this will be in the upward direction and equal to the weight of this fluid displaced. That is what Archimedes said. Okay, let us understand why is this statement correct. Okay, what we will do is we will remove this body. Okay, in place of this body, let us draw one boundary here. There is liquid now, this is not the body, it's just that liquid is there here. Let us draw the boundary like this. Now at every point, suppose at this point, if the pressure was H rho G, now here also what is the pressure? H rho G only, the direction is also the same, because exactly the body shape I'm cutting it here, and the fluid, on that fluid I'm seeing what is happening. At every point the pressure is exactly what it was before. Okay, now this body of water which was there in the flask, is it in equilibrium or not? It is in equilibrium. That volume of water which was there, it is at rest. If it is in equilibrium, then the net force on it must be 0. What are the two forces acting on this liquid, this part of the liquid? One force is its gravitational force, and the other force is this pressure force which is acting everywhere. So if it is in equilibrium, this gravitation force must be equal to the net pressure force on it. Okay, so this net pressure force equal to the gravitational force of this fluid, and this fluid is nothing but which was displaced by this. So the buoyancy force on this equal to the weight of displaced fluid. That's it. Okay, so what is the expression, tell me, for this? What is the expression for this buoyant force? So buoyant force equal to weight of displaced fluid. Okay, so buoyant force equal to Weight is nothing but m into g. What is the mass of this fluid, which is this mass is density into volume? So our volume displaced into weight of fluid. So density of fluid, weight, that is nothing but into g. So that's it. This is nothing but the buoyant force. Volume displaced, density of fluid into g. So I hope we are clear why the formula V rho g has come for buoyant force. Now I'll teach you a very important skill. Okay, that is floating on water. If you know physics and if you have faith in physics, then you can easily float on water. The human body, suppose we take out all the air from the human body, our density of the human body is slightly greater than the specific gravity of the human body, slightly greater than 1. So what happens is, if we exhale all the air out, we will sink. Okay, suppose we take air in and the density becomes, specific gravity becomes slightly less than 1, so we start floating. Okay, so very important skill. Suppose you are very far from the shore, don't try to keep on swimming, you'll lose energy. In between, just lie down like this. Okay, take in air fully, lie down. At times you'll have to leave out the air. When you leave out the air, you start sinking. So at that time, just flap your hands little, you'll stay afloat. Then again take in air fast, again you'll float. Okay, so important skill.